Hi students, MCQ number 5. The electrostatic force of repulsion between two positively charged ions carrying equal charge, and that is 3.7 into 10 power minus 9 Newton when they are separated by a distance of 5 angstrom unit. What are the number of electrons missing from each ion? Very simple numerical. So first, what is the force? Force of repulsion between the two charges, that is given as what, 3.7 into 10 to the power of minus 9 Newton. Okay, and the distance of separation D is equal to 5 angstrom unit, that is equal to 5 into 10 power minus 10 meter. So we will take the two charges, identical charges, as Q and Q. So now K into, okay, Q1, Q2. So Q into Q divided by D square, the distance square, is equal to 3.7 into 10 power minus 9 Newton. Now K value is 1 by 4 pi epsilon naught, can be taken as what? 9 into 10 power 9. Okay, 9 into 10 power 9 into Q is what? Q square divided by D square, 5 into 10 power minus 10 whole square. So 5 into 10 power minus 10 whole square, and that is equal to 3.7 into 10 power minus 9. Okay, so once again 5 into 10 power minus 10 whole square we will expand. So left hand side is 9 into 10 power 9 multiplied by Q square divided by 5 square is 25 into 10 power minus 10 whole square is 10 power minus 20. So that's equal to 3.7 into 10 to the power of minus 9. First, we will get the value of Q square, then take square root and get the value of Q. So what is Q square? Q square shall be written on the left hand side. So Q square is now equal to 3.7 into 10 power minus 9 multiplied by 25 into 10 power minus 20 divided by 9 into 10 power 9. So this is 9 into 10 to the power of 9. So Q square is now equal to 3.7 into 25. Separately I have multiplied them into, now you see here 10 power minus 20, this 10 power minus 9. If it is added, it will become 10 power minus 29. This 10 power 9 also will come to the numerator. So totally this is a 10 power minus 9 minus 20 again minus 9 and whole divided by 9. So this must be equal to product of 3.7 into 25. So this is 92.5 divided by 9 into 10 raised to the power minus 38. So if you divide 92 by 9, it is more than 10. So if you divide, you will get 10.27 into 10 to the power of minus 38. Okay. Therefore, Q is now equal to square root of 10.27 into 10 to the power of minus 38. Now if you take the square root of 10.27, you will get the 3.2. Okay, 3.2. That is the square root of 10.27. And the square root of 10 power minus 38 is how much? 10 power minus 19. So we get the quantity of charge with each sphere is 3.2 into 10 power minus 19 coulomb. But what is the question? What are the number of electrons missing from each ion? Each ion is having a charge of 3.2 into 10 power minus 19 coulomb, and that is equal to integral multiple of the electronic charge. So from the quantization of energy, Q is equal to N into E, where E is the charge of the electron. Okay. Therefore, N is equal to Q divided by E. So this is now equal to the quantity of charge with each sphere is how much? 3.2 into 10 to the power of minus 19. And the charge of the electron is 1.6 into 10 to the power of minus 19. So this power 10 power minus 19 get cancelled. Therefore, N is equal to 1.6 into 2 is 3.2 exactly. Okay. So the number of electrons missing from each sphere must be equal to 2. So which is the right option? That is B. Okay. Therefore, option B is the correct answer. Now at the beginning stage, the problem appears to be very lengthy, but again and again when you do means you will have some shortcuts. So where we will have to spend much time is to find the square root of this number, that is by practice. Okay. So you can guess approximately this is nearly twice the charge of the electron, like that you will have to practice. So here we use the concept, first we use the concept Coulomb's inverse square law, and then what is this? Q is equal to Ne, that is the law of that's quantization of the electric charge. So from that we have found that the value of N is equal to 2. I hope you must have understood well. Fine.